Hello my dear student, hope you are fine and taking care of yourself at your home. Today we will do the recapitulation of the chapter. As you know that we have completed the chapter. So before starting the recapitulation of the chapter, please do like and subscribe my channel and press the bell icon button for further notifications. So let's start the recapitulation of the chapter.
All bodies in the universe attract each other. The force with which all bodies in the universe attract each other is called gravitational force. The revolution of the moon around the earth is also a result of gravitational force, which acts towards the center of the earth. Such a force exerted on a body moving in a circular path that acts towards the center of the circular path is known as centripetal force. Newton originally thought that like an apple or a ball, all objects should fall to earth. However, based on his study of centripetal forces, he was able to explain why this does not happen. When a body A is in circular motion around another body B, it experiences a force directed away from the center of the circular path, which is equal in magnitude and opposite in direction to the centripetal force. This prevents the two bodies from moving towards each other due to gravitational force of attraction between them. This is the reason that the moon and the planets revolve in their respective orbits instead of falling on each other. For a better understanding of centripetal force, let's observe a game of hammer throw, an Olympic athletic event. Each thrower swings a hammer around and releases it at a point such that the hammer flies off in one direction. You can observe that the hammer gradually gains velocity as the thrower swings it around, and the hammer flies off in a straight line which is tangent to the circular path of its revolution. While the athlete is swinging the hammer, that is, the hammer is in revolution, its direction of motion and hence its velocity changes continuously. This change in velocity produces acceleration on the hammer. This acceleration is directed towards the center of its circular path. Acceleration directed towards the center results in a force directed towards the center. This force is called the centripetal force, which means a center-seeking force. The reason for the motion of the moon around the earth is similar to that of the motion of the hammer just discussed. The gravitational force of attraction between the earth and the moon provides a centripetal force for the moon, the force that holds things to earth. The occurrence of tides due to the motion of the moon and the sun. The revolution of the moon around the earth. And the motion of planets around the sun. What do you think is common among all these phenomena? Nothing, you may say. However, through the universal law of gravitation, Newton explained the relationship between several such phenomena that were earlier thought to be unrelated. Newton's universal law of gravitation states that every object in the universe attracts every other object with a gravitational force, which is directly proportional to the product of their masses and inversely proportional to the square of the distance between them. The gravitational force acts along a line joining the centers of the two bodies. The law to an object up, it comes down due to gravity. Thus, when an object such as this boulder is pushed or thrown from a height, it falls to the earth. Such an object is said to be in free fall. An object is in free fall when it falls to the earth under the sole influence of gravity. A fruit falling off a tree or a sandbag thrown off a hot air balloon hurtled towards the earth in a free fall. However, a parachutist descending from an aircraft is not in free fall, since he uses the parachute to counter the gravitational force of Earth. A freely falling body is always under the influence of the gravitational field of the Earth. But not all the bodies under the influence of the gravitational field of the Earth are freely falling bodies. A body under the influence of Earth's gravitational field can be a body dropped from a certain height, like a ripe fruit falling off a tree. A body projected vertically downward from a certain height with some velocity, such as a ball thrown down by a boy from the 5th floor of a building. Or a body projected vertically upward, for example, a stone thrown vertically upwards. Objects in free fall move only in one direction. However, their velocity changes as they fall. A change in velocity results in acceleration. The acceleration of a freely falling body due to the gravitational force of the Earth is known as acceleration due to gravity. Acceleration due to gravity is denoted by the small letter g and is measured in meter per second square. 60 kilograms, 80 kilograms. What we popularly refer to weight is actually mass. So, what's the difference? How can you gauge your real weight? Mass is the amount of matter contained in a body, while weight is the force with which a body is pulled towards the center of the earth. Thus, weight is the product of mass and acceleration due to gravity, that is, W is equal to mg. The value of g is approximately 10 meter per second square. Thus, if your bathroom scales show a reading of 60, your weight is 60 multiplied by 10, that is 600 Newton. Mass is a scalar quantity, hence it can never be zero. However, weight is a vector that can be zero when the acceleration due to gravity is zero. For example, in space. In the SI system, mass is quantified in kilogram, while the unit of weight is Newton. A physical balance is used to measure the mass of a body. Weight is generally measured using a spring balance. The mass of a body is universal, meaning it remains the same throughout the universe. The weight of a body varies from place to place depending upon the gravitational force on the body at that place. This means that your mass on the Earth and on the Moon would be the same, but your weight would differ, because the acceleration due to gravity on the Moon is different from that on Earth.